Now, this lecture contains upstream, midstream and downstream oil and gas basic description, and I will focus more on upstream side. So, upstream oil and gas, when you are talking about exploration, drilling, completion, and then you are producing. Okay, so before you get oil and gas or maybe petroleum or crude oil, so you have to go through the phase exploration, drilling, completion and production. Once you get that produced fluid, let's say gas or oil, that will be separated in during production stage, then you will go to midstream. Midstream is basically the pipeline transportation or trucks transportation, or maybe ship will be there, it will be transported from one location to another location. Whether a destination location will be the refineries. Yeah, so this course does not contain the refineries and midstream section. We are focusing basically on upstream sector. So, upstream, and this course especially, it will be including one artificial lifting technique. Lifting techniques. So, every stage there are difficulties. For example, in exploration phase, you have to use several instrumentation and several theories or technologies are there, which will be giving you the overview that how much oil and gas is there in certain locations, in certain field or reservoir. Then once you find that you have sufficient amount of oil and gas, then you try to drill that area. So, that area, the reservoir area, you drill and you get oil and gas. Now, when you are drilling, you have several issues. For example, it can be uncontrolled flow, because reservoir pressure is very high. Suddenly, if oil and gas is gushing out, then that can be disaster or dangerous. That several disasters happen because of that reason. So, then you have to control the flow and you have to drill. Once drilling is over, then you have to complete the wellbore. When you are completing, actually you are you are making the wellbore. In drilling stage, you are drilling a hole and it will be producing oil and gas. In during completion stage, actually the drill wellbore will be producing, but that can be uncontrolled, but there will be several issues. So, during completion stage, you solve the issues and you make the wellbore for production. And what are the completion stages? Like it will be cementing, it will be like if putting pipe properly, you have to fix chemistry and other valve operating valve systems, you have to connect piping systems, you have to put artificial lifting systems, etc. Then once everything is done, then you hand over the task to production engineers. So, they will be getting stable production for a longer period. So, oil and gas engineers target will be like produce oil and gas optimally. It is not maximization. For example, if you want to maximize today, say today you are getting 100 barrel per day, tomorrow you may not get the same production rate. There are reasons, because if you are getting very high production rate today, tomorrow there will be water coming out instead of oil, or maybe sand is more. That is why the production engineer will be optimizing the production, not maximizing. Now, next thing is that when you got produced fluid like say oil and gas, then you send to downstream through midstream to downstream or refineries. After refineries, you are getting diesel, petrol, naphtha, kerosene, aviation fuel, many other fluid you can separate, and other things also you get like plastics and many medicinal compound also you can get from the refineries. So, oil and gas or the petroleum product, whatever you are getting, that is actually not only fuel, but it is having some other applications also. That is why this oil and gas exploration and production will continue for several decades most probably. So, when I am talking about upstream oil and gas, there are two types of wellbore, actually offshore wellbore, onshore wellbore. When we talk about offshore means the term says like this related to ocean. So, like say you have ocean seabed and you have land, here lots of waters are there, lots of water, and you have oil reservoir here. sometime you will have reservoir here, say on land area. So, in when you are drilling offshore area and you have reservoir, so you must have some platform, semi-submersible or maybe drill ship, and there will be mast or derrick. Then you drill a hole up to the reservoir. Okay, semi-submersible. Okay, and this is a rig, drilling rig, and this is the drilling pipe, and this is the seabed. Okay, so when you drill a hole, so you have to pass through the water. Lots of water is here. Okay, so this water actually will have lots of motion, say because of wave motion, because of current motion, and your semi-submersible will have wind load also. If wind is blowing, then semi-submersible is completely floating the ship. It will be moving left, right, forward, backward, and it will have vertical motion also. So all type of motion will be there on this drilling rig. So in that case, what you have to do, you must have one satellite positioning system. So satellite will be sending signal, and signal will be controlling your drilling ship or drilling vessel position properly. If it is not positioned properly, the pipe will be getting broken, or it will be swayed away from the actual reservoir area. So sometimes it will be moored, sometimes it may not be moored. Now if you have land well, so land well you don't have such water motion related issues. Okay, so you drill directly to the reservoir and get production. So now you know the difference between offshore wellbore and onshore. Onshore or land wellbore, and offshore means you need one ship or some floating platform or some sort of platform, and you have to drill, you have to send your pipe through water, and you have to send to reservoir. So this is the technique for offshore drilling. And for onshore drilling, directly you can put your drill pipe to the reservoir. Once drilling is over, you have to complete the wellbore properly, then after that only you can get production. And there are different types of platforms are there. For example, one I have drawn here, it is semi-submersible. Semi-submersible jack-up rig, gravity based structure, shape, drill ship, movable drill ship, they say movable offshore drilling unit, this is MODU. So you drill a wellbore and then again move the drill ship to another place to drill another hole. Okay, but for onshore application you don't have such big semi-submersible ships or jack-up. All these options are not there. Just you move using truck, or maybe if the area is inaccessible, then you can use helicopter to transport your rigs with the proper location. For example, you are drilling an area inside a forest, so there may not be road connection. So in that case, helicopter also can transport drilling equipments, rigs, and clean the area and start drilling, get production. Now drilling. So when you are going for a drilling, then first I said like there will be exploration phase. So exploration phase, you evaluate how much oil and gas is there and what is the depth, and that sort of prediction you do. The next phase is drilling. When you are going for drilling, so drilling will contain like whether you need a platform, or you need just derrick and mast, or you need a drill pipe to carry, or you need to get clearance from government agencies. So lots of activities are there before drilling. Then your I already told the platform will be there, and when you are going for a drilling, then one mud system will be there. I will explain later. So mud system is like this. When you drill a hole, you may have seen the drilling of any metal cutting machine or drilling, or wall drilling for putting a nail. So many times they will be putting some liquid also, so to lubricate, and so that the drill cutter will be moving faster and safer way. Then there will be derrick or mast. Derrick or mast, for example, it is like this. Okay, so all the drilling operation will be done from this mast only. Okay, and they will be on a small platform. So over the platform there will be, this is platform. Okay, and there will be one pipe, so pipe will be connected. When you are going for a drilling, there will be one pipe connection. So pipe will be giving drilling fluid actually. Okay, and drilling fluid will be passing through this drill pipe. This is called drill pipe. And this is called derrick. Then this is drill pipe, and when you drill a hole, there will be one drill cutter here. Okay, and the drill cutter will be cutting, and this drilling mud will be passing through the tube, and the drilling mud again will go back to one pond. Okay, so from there again you have to pump drilling fluid. So this is simplest picture. I will draw on a detailed picture again. This is drilling mud, drilling. Now preparing rig site. So the drilling area, after exploration, you found that area is inaccessible. Inaccessible means it may be lots of forest will be there. Okay, lots of forest will be there, and you got one reservoir here. Okay, lots of trees are there. There is no accessibility. Then how will you drill there? Then you have to make a road maybe, or you have to plan to transport by helicopter. If you have road, then you must use truck. Many times there will be road nearby, but there will be no connectivity between your drill site and the road. So in that case you have to prepare the road. Before preparing road, then you have to get permission from the landowners who are having land to access this reservoir. Okay, to access this area. So then you have to get permission from the landowners. You have to get a road. You have to clean the area. Maybe if it is forest, then maybe you have to cut a few trees, and you have to make the land clean. You have to make the land smooth, and you have to create some pit. Sometime you have to create pit or mud pit. Mud pit. Mud pit means I already told the mud or drilling fluid will be circulating, so that drilling fluid should be stored on a mud pit or on like small pond actually. So there the drilling fluid will be stored. You have to prepare that one. Then you have to create some small houses for keeping the engineers, the technicians. Then there will be food restaurant, small restaurant system, so that people can eat. There will be toilet system, there will be a power connection system. So everything you have to prepare before you start drilling. So this part also very important, because you have to get all the land permissions and local environmental permissions, government permissions, road construction. You have to bring all the pipes, derrick, mast, truck, and you have to make small houses. You have to make mud pit. You have to smoothing the land. So all the tasks you have to do before actual starting of drilling. So that is called preparing rig site. Okay. Next is drilling stage. Now you prepare drilling the site, and everything came up like one drilling rig system with the derrick, and then you brought your all the pipes, drill pipes, casings, and then mud handling system. Then you need cement handling system. You need power source. Power source means like if you have electric connection, maybe you can take directly electricity, but normally they will not be. So in that case you need to bring your IC engines. IC engine I will discuss later. So IC engine will give you power, like trucks, bus running using IC engine or internal combustion engine. So I will discuss later. So that IC engine will give you power. So that power you have to convert into electricity. That electricity will be running your many items, including your geyser, your water system, your drinking water, your taking bath, or food item will be there. So you have to cleaning, and other thing also you have to do using some power. So that IC engine will give the power. So basically diesel engine will be there, first stroke diesel engine. Now when you are going for a drilling, so you need to carry drill pipe. So drill pipe are like metal pipe actually. It's simple metal pipe, several feet long, maybe 30-40 feet long, and this pipe will be carrying drilling fluid. So here I will draw again this drilling picture. First you drill a hole, then drill pipe will be having like this vertically, okay, and this is the surf earth, and this is drill pipe, and you have drill cutter like this, okay, and this is called drill collar. This is drill bit. This is drill pipe. And there will be one pipe connection like this. This pipe will go, okay, this pipe will go to mud pit, okay, mud pit. So when you are drilling, so this will go to one platform like this, okay. Okay, so here I will draw one derrick also. I'll change the color. So it will be like derrick with change color I am drawing. It will be civil structure actually, so that's why I am drawing like this. If you see from long distance, it will look like this, okay, derrick. So this is derrick. And this is called drill pipe, and this is drill collar. This is called mud pipe. This is pump, mud pump, and fluid will be flowing like this. Fluid is coming like this. Mud will be stored in mud pump, and before mud pump actually there will be one shale shaker. So I am drawing like this, shale. Okay, during drilling, your fluid will be pumped through this, and drilling fluid or drilling mud, it will pass through this small holes will be there, okay, and drill cutter will be cutting the rocks, okay, drill bit or drill cutter or cutter, it will be cutting rocks. So when drill bit or drill rocks are getting cut, so there will be friction, lots of friction between drill bit and the rock. Because of that, there will be heat generation. So what mud will do? Mud will reduce the heat and it will lubricate also. Because of lubrication, the heat generation will be lower, and if heat is generating, again mud will be removing the heat because constantly the fluid will be circulating. So that circulation fluid will be taking heat. How it will be circulating? Like say fluid will be exiting, again it will move up after cutting, okay, it will move up like this. I'll make different color that will look better. So it will go like this, it will go like this, then it will go like this, then to go, it will go like this, then again. So this is the mud flow loop, okay. So whatever mud you prepared, so mud basically it will have bentonite type, maybe bentonite. Bentonite you mix with water and you get drilling mud. Sometimes you add some other type of chemical also, for example caustic soda you add sometimes. So to change the drilling fluid properties, you need to increase viscosity, sometimes decrease viscosity, sometimes increase density, sometimes decrease density. Let's later why drilling fluid is property is also important for this application. First, understand the loop. So, loop contains one drill pipe is coming down from vertically from top to bottom. Okay. So, drill pipe coming from top to bottom, and bottom there will be one drill cutter. Drill cutter will be rotating continuously. So, from the top, from direct side, there will be also mechanical arrangement. So, there you are rotating drill pipe continuously, like continuously it is rotating like this. When it is rotating, you are cutting rock, rotating, and you are pressurizing also. So, same time the rock will be cut. Now lots of small particle will be chipped, will be coming up because of rock breaking. So, that rock particle, if it is standing there or staying there, then you cannot cut, actually it will be stuck, the pipe. So, what you have to do, you have to lift the rock to the surface. So, when you are lifting, how to lift? So, drilling fluid is having high viscosity and density also. Because of the high viscosity, the rock particle will be moving up with the drilling fluid. So, you inject high viscosity fluid without rock particle. Then when you mix with rock particle, when drilling fluid is moving up, so rock particle also will be floating with it and it will be moved up. And when it is moving up, first you will pass through the shale shaker. Shale shaker means there you one mesh will be there like this and continuously shake. When you are continuously shaking, so what is happening, and what fluid is passing over it. So, fluid is passing, continuous shaking. So, liquid or fluid will go down and the solid rocks will be holding on above it. Then the rock you separate, big rocks or bigger size rocks you separate, and the liquid will be falling down. The liquid you put in mud pit. Okay. When you put in mud pit, but before that also sometimes there will be centrifuge or centrifugal, because of centrifugal action you separate smaller mud particle, that rock particle also from the mud. So, once you set bigger particle, separate bigger particle, smaller particle, then store that same fluid in mud pit. That then mud pit again store for certain time, so that any further lower smaller particle will be settled down there. From mud pit you again mix with certain desired fluid, desired chemical if required. Otherwise, you pump the same fluid to mud pump, using mud pump, then mud pump to your Kelly. This is called Kelly actually. The before drilling pipe, the section is called Kelly. So, through Kelly you pipe, the fluid will go to the drill pipe and drill pipe to your drill bit. So, the whole loop will continue in the during drilling process. And sometimes you need so purpose of drilling fluid purpose of drilling purpose of drilling fluid is to give enough viscosity, so that, or to lift the drill cutting from the wellbore to the surface. So, cutting transport, PORT. Okay. Next is it will reduce temperature, so cooling of drill bit. Next is creating hydrostatic pressure. So, why hydrostatic pressure is required? So, when you are drilling a wellbore, so I already discussed in another lecture that when oil and gas is stored in certain rock area, so there will be one formation area where oil and gas will be there, then there will be one cap rock. So, when you are drilling from vertically, so there will be one cap rock, then cap rock when drilled, then suddenly it will come to formation or high pressure zone. So, if you are not controlling the pressure, the high pressure fluid will be pushing up everything from the wellbore to the surface. So, that can be disaster sometime. Disaster means like if uncontrollable gas and oil is coming out, and if there is any small fire source, then everything can be a big blast. So, to avoid that one, what they do, drilling mud will have certain amount of pressure. So, if there is any extra pressure coming because of drilling, once you cut the solid rock, strong rock, then you got high pressure area. So, because of high pressure, fluid will try to enter through your drilled hole. So to avoid that one, you inject very high pressure drilling, high density drilling fluid and create high H rho G. High density means H rho G pressure, right? If you increase rho, then your pressure in the drilled hole will be very high. So if reservoir pressure is very high, still our wellbore that drilling fluid pressure will be much higher than that one. Because of that one, the reservoir fluid will not enter into the wellbore. Okay, when it is not entering into the wellbore, system will be safe. But in certain case, if pressure is very high, still you cannot control, then there will be another mechanism called blowout preventer. I'll discuss later. Okay, now you drill a hole. A mud system is there. You understood the mud purpose is there to cool drill bit, to lubricate, and to maintain hydrostatic pressure. Now everything is done. You are drilling a hole. First you drill a hole, then you want to get more production. So what there will be different types of holes. For example, you have vertical hole. Okay, you drill a hole vertically. Another possible that you drill a hole vertical and go horizontal. You go slant, you go like this. So different types of holes are there. Or wellbores. Okay, and vertical well is very easy to drill, but there is issue if you think that reservoir is like this, very thin reservoir, and you want to get more production. So in that case, this vertical wellbore will give very small connection area. So fluid will be entering through these holes and flow rate will be very low. In that case, what you do, let's say reservoir is like this. For example, this wellbore, this is 1, this is 2, this is 3, this is 4. So in that case, you perforate. So you are getting longer connectivity area, right? So and in this case, you are getting only this one. So L is longer in case 2. So case 2 longer means you are getting more production actually. So your flow rate will be more. But in some cases you make horizontal also based on your reservoir sizing or conditions. In some cases you make like this also, S shapes also. So many different shapes also possible to produce. And many cases these are reservoir condition, and another condition can be remote areas. For example, you want to drill a hole inside IIT campus, but IIT or government will not allow. Then what you do, you drill a hole outside IIT campus somewhere land is available. Okay, so this is your IIT campus, and where land is available is here. So what you do, you drill a hole here, go to here. Okay, horizontally you access that area. So IIT will not know, but the oil will go from IIT actually. Similarly, if you have like say offshore area like this, okay, lots of water is there and here. So instead of going to ocean, so you drill a hole here and you reach to a reservoir. Okay, so drill a hole here. Geological isolation, in some cases you cannot drill directly in the reservoir. So in that case also you have to drill horizontal or S shape or other shape hole. Instead of vertical, you can drill other shape of hole. So if there is accessibility difficulty, for example, if forest also there or city there, or maybe some pond or some other things are there, so in that case you go horizontal or you make different types of hole instead of vertical, and you get more production. So finally you want to get more production, which will help you in economy, for company's economy as well as your country's economy. So the engineers they thought many types of holes, and they are trying all over the world. Even in India, Mumbai High, initially they drilled vertical hole, later they drilled horizontal wellbore. So they are getting more production actually. And multilateral, another option is the multilateral. Multilateral means you drill a vertical hole, multilateral here, multilateral. So in multilateral wellbore, what you do, you drill a vertical hole, then you do some branching like this. For example, you have certain oil or gas source, some oil gas source, some oil gas source here. So you can get all the oil and gas from one single surface condition. Let's say where is the location? For example, offshore drilling, you have one big platform, and in that platform actually you are having all this drilling mechanism like mud handling, everything, and you have to access multiple areas, several kilometers, 2-3 kilometers, 4 kilometers, and you want to get more production. So one platform, a very expensive platform, is very expensive actually, because you need satellite communication, you need radar, you need thruster, you need and normally the oil and gas platforms will be mini town. The engineers will be working there, and there will be swimming pool, there will be sports, everything will be there. So this helipad will be there because for accessibility. So this will be largest man-made structure. If you see search Google, you will find largest man-made structure. Those are actually semi-submersible or floating platforms. Those will have only single access point, but when it is reaching to reservoir, so it will have multiple branches. One branch, one reservoir, another branch, another reservoir, another branch, another reservoir. Again, sometimes you do selective perforation, selective drilling. So in that case, what happens? You have multiple layer of reservoir. One reservoir for gas, one for oil, one for. So in that case, you drill a hole. You put one pipe for gas, one pipe for oil. So that different types of hole they will make, different types, horizontal, vertical. Again, they will make multilateral also. Okay, so multilateral will be branching like this, can be branching like this, or can be branched like this. Okay, so many types of people are trying, and day by day technology progressing, and the wellbore complexity also getting increased, and they want to get more production with minimum investment. So that is the main purpose. So that's why they are making all these different options of drilling hole. Now, during drilling, I did not talk about casing and cementing. You drill a hole. Okay. So what you do? Initially, you bring all the items after preparing the area. Then you drill a big hole, the 36 inch about. Then 36 inch drill a hole. Then you put one casing, metal pipe. I'll put different color. Okay, so once you put casing, then you put cement. This is cementing. Okay, this is cement. This one and cementing color is different. Cementing color is this one. Okay, so do cementing. Then normally this hole will be 36 inch. 36 inch. Then you put one pipe, metal pipe, that is called casing. Then in between that rock or mud and metal pipe, you put cement, normal cement, like you are making house, that cement, Portland cement or the cement, and you put pipe and cement it properly so that no mud will be coming in or it will not be moving. Then after putting a few feet of that larger casing or conductor casing or surface casing, then you put another casing, and you make another hole, another pipe you put, and you make another cementing. Okay, so gradually top portion will be wider, then you cement it, then you put another narrower pipe, drill, then again you cement around. Again you put another narrow pipe, again drill, again cement. So it will be like this, wider, then another pipe, then another pipe. Okay, so the surface casing will be there, like surface casing, conductor casing, okay, surface casing, conductor casing, then there will be intermediate casing, surface casing, maybe conductor casing, then will be another intermediate casing. Then there will be finally production casing. Okay, so every time you have to cement, and finally you are getting production casing. Okay, When you are giving production casing, that will have perforations, maybe lots of holes will be there, that is called perforation. And this is production casing. Production casing, and production casing will go up to the surface, and these are already blocked anyway, this is cemented. And this production casing actually will be producing oil and gas. Okay. And every time you have to cement it, so that this purpose of cementing is that the hole will be stable. Let's say you drill a hole, if you are not cementing, then pipe will be moving here and there, and then mud will be falling down, and the hole will be unstable. So you put cementing with high pressure. So how to cement it? So you drill a hole, you put a metal pipe, then you inject very high pressure cement mixture, cement and slurry you create, and you mixture and pump it at very high pressure. When you're pumping, it will fill all the gaps in between mud and the pipe. When the gap is filled all around, you give some time for settling. On settling done, again you put another pipe, drill pipe, and start drilling. Drill further, maybe 100-200 feet. Then again you put mud, again cement it. So and surface area, like say 100-200 feet, actually very you have to make very safer zone, because that area will be trees will be growing, your drinking water will be available in that zone, and all some surface leaches and other things will be there. So in that area, no liquid, low wellbore fluid, let's say hydrocarbon, should be leaking in that area, otherwise the trees will be destroyed and environmental issues will be coming up. So surface area will have water, several types of cementing. So that's why surface area will be much more safer. And when you are going drilling down after maybe 500 or 1000 feet, there will be no such issue. So in that case, maybe open hole drilling, sometime we do open hole completion, so no cementing will be there. Sometime will be cased hole completion, sometime will be sand control system will be there. So those cementing system is to make hole stable and to make safer, and so that, and again liquid should not wellbore reservoir fluid should not enter into pipe, or piping fluid should not go into reservoir, that also it will ensure. So that's why there will be several level of metal pipe and cementing options. And cementing will be done from surface, and the surface there will be cementing pump. That pump will be delivering very high pressure cement mixture, Portland cement normally. So that cement mixture with different agent, for example some agent will be reducing settling time, some will be changing viscosity, so many parameters will be there. So based on that, the engineers will be deciding what type of chemical should be added in the during cementing process, and should be settled properly. Then again drill, and the drilling hole can go 100-200 meter to several kilometers, 5000 feet depth, 10,000 feet depth wellbore is common, and horizontal wellbore maybe 10-20 kilometer also will be common. So based on the requirement, the engineers or the experts in oil and gas who are working in the field, they will be deciding whether it will be horizontal wellbore, vertical wellbore, or multilateral wellbore, and the decision will be taken based on feedback from the reservoir engineer, from exploration engineer, and from initial information from other hole drilling. Okay. And the other conditions also there, whether accessibility. If that area is inaccessible, then you have to drill other area, and you have to go horizontal, and you have to access the reservoir area. And before drilling, again permissions are required.